So today we're going to be talking about cancer. And there's really kind of three main causes that come with cancer that we want to understand. So let's start with what's the cause of cancer. First, we know genetics. And we're relatively still in the new age of understanding how genetics is related to cancer. But we know it is. We know there's something in there. But the interesting part about genetics, while we can say that, oh, it's related to cancer, it's really only about 10%. So 10% of patients that have cancer is related to genetics. And the reason being is that when we have our chromosomes, right, we have that going on, we're given the cellular mutation or the genetic mutation, and it's usually only on one side. For cancer to be full-blown and really aggressive and going, it has to be on both sides. And once it's on both sides of that chromosome and it's in the DNA and it's a mutation that's happened there, that's when cancer becomes a big issue. So most people are only born with one side of it, if it's a genetic component and given to them by a familial parent. But really, really interesting is we like to pinpoint genetics when really genetics doesn't have a huge component of it, but it can have some. And understanding that genetics is part of cancer helps us understand different ways that we may test. So if you have a family that has BRCA1, BRCA2 genetics or any of the prostates, but specifically like the breast ones, we know that a mammogram is not going to be our best way of screening and watching for it. We're actually going to start doing breast MRIs to watch for it so we can catch it sooner. So if we know somebody has a genetic precursor to a cancer or a cancer type, then it changes how we screen for it. So that's something to pay attention to, but it's only 10%. So really, when we're talking about cancer, it's not usually our huge causation factor. The biggest causation factor is chronic irritation. So this means this is life choice to some degree. And it's chronic irritation that is happening inside the body. So there's an interesting, when you look at the numbers, in the Midwest, we have more occurrences of bowel cancer or colon cancer. Why? Well, because we like meat and potatoes, right? We're good old farm kids. We like our meat and potatoes. Well, our gut needs more of the roughage and more of that fibrous diet to help push through and cleanse. So it's that chronic irritation to the colon of our heavy meat and carb diet that is actually causing chronic irritation, inflammatory process, and it allows the cells to mutate and change. All right, so that's where it comes from. You don't get skin cancer from one really bad sunburn. You get skin cancer from multiple sunburns and multiple exposures. That's why most people that have skin cancer, they have it like on their nose or the tops of their ears. Our bald friends have it on like the tops of their heads, shoulders, sometimes backs. Very rarely do we have skin cancer like on the bottom of a foot. Okay, because that doesn't see as much sun. It doesn't have that chronic exposure, that chronic irritation. So smoking, it's not that one cigarette you smoked when you stole it from your dad when you were 16 years old that's going to give you lung cancer. It's the chronic irritation that causes the genetic mutation that causes the cellular damage that then causes the cancer to happen. So that's one of the important things. The third reason, it's just bad luck. You cannot tell me that one of the kiddos that I took care of that was 3 years old did anything chronically to irritate the body to cause that type of cancer. There is some cancer that just happens to be bad luck. And those are kind of the three big things that cause cancer. We don't know. This is the I don't know. They'll call it idiopathic, right? They don't know. So bad luck happens. Genetics is about 10%, but the majority of the time it's a chronic irritation. A lot of our breast cancers are caused by estrogen. They're caused by obesity. They're caused by, or at least those are links to it. Cancer also isn't one of those things. It's not 2 + 2 = 4, right? It's 2 plus 2 plus 2 plus 2 equals 4. Well, a couple of those 2's didn't count, but a couple of those 2's did, and so it's that there's no like this, unless it's like smoking. Then we know that one's a pretty direct link. Radon is one we see. So we have a lot of lung cancer here in the southeast Nebraska area because our radon exposure is so much more than other locations. So different areas in the United States will have different amounts of cancers depending on what they're chronically exposed to. That's something really interesting when you start looking at cancer. The other thing that we want to know is how bad is it? This is a huge piece of how bad is this cancer? When we're talking about cancer, when we're talking about how bad, when you're a nurse and you're reading the reports, there's a couple terms that we really like to understand. Differentiation or differentiation. It's a big long word, but break it down. Different, okay? Each one of our cells in the body looks different. A heart cell looks like a heart cell or a cardiac cell. A renal cell looks like a renal cell. A lung cell looks like a lung cell. So those are the cells that we're used to seeing. We can look under a microscope and we can differentiate them very easily because they look different. But when we start having cancer, when we start having mutation of the cells, these cells start to slowly, not quite, look like themselves anymore. Okay? And still, at this point in time, we can still kind of differentiate. At least we got our cardiac cell we can differentiate, our renal cell we can kind of see, and our lung cell we can see. But if we get to a point where we can no longer tell which cell that is, we are now poorly differentiated. And when somebody is poorly differentiated, that means we can't tell the different structures of the cell. We may not even know where the cancer cell originally came from. I always like to say, like, if your kid that likes to poof the dandelions and you blow on them and watch the seeds go everywhere, when that seed goes into the neighbor's yard, that seed doesn't grow a rose. It doesn't grow a daffodil. It grows a dandelion. Cancer cells are the same way. Even though this cell may have originated in the renal area or in the kidney, wherever it goes to, it's going to grow renal cancer or kidney cancer, okay? So, or this one was our lung cancer. You can't really tell anymore because it's poorly differentiated. They all look the same. They're all these blurry blobs that you can't tell the difference from. So this one is going to still grow lung cancer. It's really, really important for us to know the cell of origin. One, because it shows if we're starting to metastasize and go other locations, but it also changes how we treat the cancer. Different cancers need different treatments, and there are doctors that are paid lots of money to study and know those differences, but they're looking for those differences. So they need to know the cell of origin, and when it is poorly differentiated, meaning they cannot see the difference, they can't see where that cell started, they're gonna run into some problems, and they have to, that's when like biopsies and stuff can take a lot longer, because they have to really dig into that cell to try and figure out what that cell originally looked like. So if you hear somebody say that they're well differentiated, and it's a long fancy word, right? Well differentiated, so they can see the difference. So maybe that would be this cell, right? You can still kind of see that triangular shape. You can still kind of see that round shape. You can still see kind of that heart shape, okay? It's still more well differentiated. And there's different scales depending on the cancers of which one it's going to be. So that's one way we can tell how bad it is. The other way we tell is what they use is a TNM system, which is tumor, nodes, metastasis. And it's really important that we understand. Tumor, nodes, metastasis. So tumor, it's the size. Okay? It's about how big that tumor is. All right, if it's a really small, they call it in situ, it's SITU, a lot of times that's really well encapsulated, and so it's not going anywhere. It's a tiny tumor. All right, so that's something that we really want to pay attention to, is that tumor. So what they do is they give numbers next to these. So if I had a T4, that's a pretty big tumor. If I had a T1, that's a pretty small tumor at that point in time. N is nodes, and it's, did it get to the nodes and how many? So it's how many nodes are we impacting now? So if I have a let's see, we'll go back to that T4. So we have a T4, so we have a decently sized tumor, pretty big there. Nodes, and we've got 3. That means we're at least into the lymph nodes. If not, we're in 3 lymph nodes, or lymph node sections, depending on how that scale is ranging. And then M is metastasis, and metastasis is very bad. M-E-T, yeah, there we go. Metastasis, okay? If we see metastasis happens, it's gonna happen like regionally first, so it's, or local, and then kind of regional, and then if it's widespread. So if you have breast cancer and it's now in the brain, that's not a local metastasis. We're now spread much further, because we're also probably in the lymph nodes at that point in time, because breast cancer seems to like to go to the brain. I'm not sure why, but that seems to be. So if you have a number beyond this metastasis, so a 2, we're in 2 different organs now. Now remember what I talked about, that cell, so we talked about breast cancer, that breast cancer that was in the breast tissue is now in the brain. It is growing breast cancer in the brain. It's not brain cancer. That's why it's really important that we understand when people say they have lung cancer with METs, it's growing lung cancer in that tissue that it's in. So if it's they have METs to the liver, it's not liver cancer that they have. They have lung cancer with METs to the liver, meaning that it has spread to the liver and it's growing in the liver. So think about what you do for those dandelions in your yard. You spray them, you try and kill them. Maybe you're a person like me that thinks they're pretty and I like them, but in the body, we don't like those things growing in places where they can't be. Our body does have some natural defenses when it comes to cancer. Our body, a couple things that have to happen for cancer to happen is we have cells in our body, and our cells kind of auto-regulate and regulate the area. So if this cell is becoming cancerous, a couple things can happen. First of all, it can go into self-destruct mode. If it goes into self-destruct mode, it goes, I don't look like the other things around me, I'm going to shrivel up and die, okay? That can happen. Or, now if you get a cancer cell or a cell that's mutating and says, I don't really care if I don't look like the things around me, I'm just gonna keep growing, the other cells can move in and snuff it out, okay? So those kind of 2 things have to happen, where the cell recognizes that it's not normal, but it keeps growing anyways. A cell, then the cells around it don't have the power to snuff it out, and then it has to multiply quickly. So even if, so since I did red and blue, we'll just do purple here, right? So then, even though the cell may not have enough, or the body may not have enough nutrition for this, cancer starts to feed itself. It starts to pull all the nutrients to itself. And so now these cells around it, they don't have the power to take this out. Think about who's at more or less risk for cancer. It's kind of interesting when we look at age. When we look at age of people, we've definitely had more, as we get older, we've had more chronic irritations, right? We've had more exposure to the sun. But when we're older, our cells grow slower. So if they're growing slower, they're not gonna be as quick. Even if they're cancer cells, they usually aren't gonna be as quick at replicating because they're slower. They're still slower just because of age and just because of genetics and just the aging process that happens. But when we have younger people who then haven't had as much chronic irritation, right? Because they haven't had as many years in the sun, they haven't had as many years of smoking, or they haven't had as many years of radon exposure or whatever. So they haven't had that piece, but their cells are healthier and younger, so then they grow really fast. So it can be really interesting to see how a young person has problems with cancer versus an elderly person with cancer. Sometimes older people with cancer will say they'll die with the cancer, but not of the cancer, because their cells just aren't replicating that fast, just because at a certain age, our cells slow down, just like the rest of us does, okay? But when we're young, our cells go faster, but we haven't had as much chronic irritation to stimulate that. So I like to think of cancer as a glitch. Everybody seems to have smartphones and computers now. Think of when you've had to power your phone or your computer down because there's been a glitch in the system, right? I've totally had that. That is what cancer is. Cancer is a glitch in the cell and in the cell reproduction phase. And so all of a sudden, that cell isn't recognizing itself. It isn't letting the other cells tell it that it's no longer the same or able to do its job. And it grows out of control without care of the food that's around it, what it's doing to the other cells around it, and what it's doing to the body. It really doesn't care about its host at that point in time. When we're working with cancer, we have to think about a couple of things, right? So we've talked about our staging. We've got the TNM, tumor nodes metastasis. We talked about differentiation. The other thing we want to talk about is the idea of size versus location. When we talk about tumor size, right? I said small. Small is definitely more curable. Why is a small tumor more curable than a big tumor? Okay? Think about that for a second. Why is a small tumor more curable than a big tumor? It's had less time to grow. It's easier to cut out. It's easier to take care of, right? But what if that small tumor is in a really important location? Like what if that small tumor is pressing on a ventral duct in your brain? So now the cancer isn't necessarily causing the death. The damage to the tissue in the brain that's not letting the ventricles drain is now causing our problems. So it's really important for us to understand the idea of size versus location and how each one can cause their own problems. So we talked about how bad it can be. We've talked about the causes, and something for us to understand is, unfortunately with cancer, it's sometimes just a crappy deal.